Iron rusts, a candle burns, milk turns to curd, food goes stale. Every one of those is a chemical reaction. New substances are being made. In this chapter, we'll learn to spot a chemical reaction, write it as an equation, balance that equation properly, sort reactions into 5 simple types, and finally see why iron rusts and why food goes rancid. We start from 0, no chemistry assumed. First, what counts as a chemical reaction? In a chemical reaction, the starting substances, called the reactants, turn into brand new substances, called the products, with different properties. How can you tell one happened? Watch for the clues: a change in color, a gas bubbling off, a solid forming in a liquid, a change in temperature, or a change of state. If new substances appear, it's a chemical change, unlike melting ice, which is only a physical change. We write a reaction as an equation. Start with a word equation. Reactants on the left, an arrow pointing to the products on the right. The arrow means gives or forms. Then replace the names with chemical formulae to get a symbol equation. For example, magnesium plus oxygen gives magnesium oxide. In symbols, that's Mg plus O2 gives MgO. That raw version is called a skeletal equation. Correct substances, but not yet balanced. Now, the key rule. Balancing. The law of conservation of mass says matter is never created or destroyed, so the number of atoms of each element must be the same on both sides. We balance by putting numbers, called coefficients, in front of the formulae, never by changing a formula itself. Take iron reacting with steam. Fe plus H2O gives Fe, 3O4 plus H2. Balance it, and you get 3 Fe plus 4 H2. O gives Fe, 3O4 plus 4H2. Finally, add the physical states: SS for solid, L for liquid, G for gas, AQ for a water solution, and any condition like heat over the arrow. Reactions come in 5 handy types. Type 1, combination. 2 or more reactants join to form a single product. Carbon plus oxygen gives carbon dioxide. Calcium oxide plus water gives calcium hydroxide or slaked lime, and that one releases a lot of heat, so it's exothermic. 2 things in, 1 thing out, that's combination. Type 2, decomposition, the opposite of combination. A single reactant breaks down into 2 or more products, usually when you supply energy. Heat calcium carbonate, limestone, and it gives calcium oxide plus carbon dioxide. That's thermal decomposition. Pass electricity through water and it splits into hydrogen and oxygen, electrolytic. And silver chloride goes gray in sunlight, breaking into silver and chlorine, photolytic. These absorb energy, so they're endothermic. Type 3, displacement. A more reactive metal kicks a less reactive metal out of its compound. Drop an iron nail into blue copper sulfate solution. The iron is more reactive, so it displaces the copper. Iron plus copper sulfate gives iron sulfate plus copper. The blue fades and a reddish-brown copper coating appears on the nail. Type 4, double displacement. 2 compounds swap their partners. Often an insoluble solid called a precipitate drops out. Mix sodium sulfate and barium chloride solutions, and you get a white precipitate of barium sulfate plus sodium chloride. The ions simply exchange places. When a precipitate forms, it's also called a precipitation reaction. Type 5 hides inside many others. Oxidation and reduction, together called redox. Oxidation is gaining oxygen or losing hydrogen. Reduction is losing oxygen or gaining hydrogen. When hydrogen passes over hot copper oxide, the copper oxide loses oxygen. It's reduced to copper. While the hydrogen gains oxygen, it's oxidized to water. One is reduced, the other oxidized, in the very same reaction. That's redox. Finally, oxidation in everyday life and the trouble it causes. Corrosion is when a metal is slowly eaten away by the air and moisture around it. The rusting of iron is the common example, and it needs both oxygen and water. We fight it by painting, oiling, greasing, or galvanizing, coating iron with zinc. Rancidity is when the fats and oils in food get oxidized, turning the smell and taste foul. We slow it with antioxidants, airtight packets, refrigeration, or flushing the packet with unreactive nitrogen gas. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds. Go. Rusting of iron is iron combining with oxygen and water. It's gaining oxygen, which is oxidation, the everyday form we call corrosion. So the answer is oxidation, option B. And that's the whole chapter. A chemical reaction makes new substances. We write it as an equation and balance it so atoms are conserved. The 5 types are combination, decomposition, displacement, double displacement, and redox, and oxidation in daily life shows up as corrosion and rancidity. Free notes with 60 practice questions are in the description. This is the start of Class 10 Chemistry on Clarix. Subscribe and keep going.